Good morning, everyone. I trust you are all well. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Today, I want to take you through the mechanics part 2, which is based on resultant vectors and equilibrium systems. Ladies and gentlemen, in part 1, we went through the document and up until question 3, but due to some technical issues, I couldn't manage to finish question 3. Then now, I want us to go through this question before we proceed to the session for today. Right. Without wasting time, let me just remind you of what we have done, and due to the network issues, I couldn't finish this question. According to the question, it was saying that the figure below shows 4 forces which lies on the same plane acting on the particles. Then the magnitude of these forces and their relative directions are shown in the figure. And the question says, find the magnitude of the direction of the resultant of the above 4 forces. And also you must give the direction of the resultant as a bearing. Right. If I'm not mistaken, we said in the last video, which for part 1, since we have the 60 Newton, we call this F1, and we call this F2, and we said the 24 Newton is the F3, and this one is the F4. Then according to what I said, let's now separate the vertical forces. Right. In terms of our analysis, we had vertical forces and horizontal forces. Then under the vertical forces, F1 was the first one. So F1 of magnitude of 60 Newton upwards, it was the first one. So I need to specify the direction. Then F2 is a horizontal. So F2 is a horizontal with a magnitude of 30 Newton to the right. That is our F2. But however, when we look at F3 and F4, F3 and F4, they're acting at an angle. So it means we need to resolve them into components using tail to head method. And to do that, it means we're going to say, we're going to have tail from the here, we're going to have tail to head, then from here we still have another tail to head. So we'll have tail to head. Then we put another tail here, then tail to head method. I apologize. With an angle of 90 degrees. So it means we're going to have the components of F3. So components of F3 will be, we're going to call these F3X. Let me just use a different color. So F3X and F3Y. So F3X and F3Y. F3X is a horizontal component, so it means it will be this side. So we'll have F3X. Then the F3Y will be the vertical. F3Y will be the vertical. Since these are the components of F3, it means we're going to have F3 both sides, F3 and F3. One uses cos and one uses sine. So let's look at the angle. The angle is 40. This is the opposite. We know the one which is the opposite uses sine according to SOHCAHTOA. Remember, sine is opposite over hypotenuse. It means this one will use sine 40. Now adjacent will use cos 40. So what is our F3? Our F3 is 24. So we're going to have 24 cos 40. This side will have 24 sine 40. So according to what we got earlier, we said F3Y, the answer becomes 15.43 Newton. And let's specify the direction is downwards. It's downwards. Okay, let me write it here because here, okay, fine. Let me just write it here. So this is going to have 24 sine 40, and this gives us 15.43 Newton downwards. Okay, so we're gonna have, okay, right, let me erase this. Then this side, it will be 18.39. We can confirm that 18.39. We have done this in the last session, 18.39 Newton. And what is the direction? Right. 18.39 Newton to the right. So now we are done with the components of F3. Now we're going to move on to the components of F4. This is our F4. It's acting at an angle of 20 degrees, which means we need to resolve that into components. Same applies, we're going to use tail to head, tail to head. So it will be tail to head. And here we're going to have tail to head with an angle of 90 degrees. So this will be F4x, and this will be F4y. So the F4y will be the vertical. So it means this side will have F4y. Okay. Let me use a different color. So here we'll have F4y. This side will have F4x, which will still have the F4 both sides. One uses this side, one uses cos. So the sign is, this one is the opposite to use this side. So it will be sine 20 degrees. This one will be cos 20 degrees. So what is our F4? Our F4 is 42. So we'll have 42 sine 20 degrees. 42 sine 20 degrees will give us 14.36 Newton. And let's specify the direction downwards. Okay, this one will be 42 cos 20. Then the answer becomes 39.47 Newton. Direction to the left. Direction is left. Right. We have done this in the previous video. Right. Now we need to calculate the resultant. To calculate the resultant, since we have both vertical and horizontal, it means we have to calculate the horizontal, the resultant for the horizontal forces and also the resultant for the vertical forces. I believe you're following. So now, so in terms of that, so what you're going to do is you're going to say, okay, right? Okay, let me confirm something here. Sine 40, 15.43, everything is fine, 60, okay, fine. So now we have to first calculate the resultant for the vertical and also the resultant for the horizontal. Then we use theorem of Pythagoras to determine the resultant of the vertical and the horizontal. So to do that, we can say, okay, fine. In terms of our analysis, okay, we can start with the horizontal. We start with F2. F2 is moving to the right. Let's take right as positive, right as positive, left as negative. This side, let's take upwards as positive, downwards is negative, downwards is negative, because these two are down, one is up. So let's calculate the resultant. To do that, it means we're gonna say Rx, I'm starting with the horizontal. So we're gonna take F2, we add with F3x, and we subtract F4x, because this one is downwards. Let me say it's left. So F2 is 30, F3x is 18.39, then minus 39.47, if I'm not mistaken. Then what is our answer? So we're going to say, right, 18 plus 18.39, 18.39 minus 39.47. This gives us 8.39. 8.97 Newton. Since the answer is positive, it means this is directed to the right. Okay? I believe you are following. So since we have Rx, then we can get rid of the components for the horizontal. Just to create a space, guys. So now we'll have the, okay, let me check something. Just a minute. 60 plus, no, sub 60. 30 plus 24 cos 40 minus 42 cos 20. Confirmation is the best. Okay, 8.92 is correct. Right. Let's now determine the, let's now calculate the resultant of the vertical forces. Upwards, we start with the upwards is going to be plus, minus the downwards F3y and minus F4y. So this will be 60 minus 15.43 minus 14.36. Up, down, down. So what is our answer? 60 minus 15.43 minus 14.36. This will give us a value of 30.21 Newton. 30.21 Newton. And it means that since the answer is it's positive, this would mean that the object, the resultant is upwards. Apologize. We check something. 60 minus 42 sine 20 minus 24 sine 40. This is 30.21 upwards. So it means now we have Rx it's right and Ry it's upward. So it means we need to construct a right angle triangle by using tail to head method. So what we're going to do, I'm going to construct a Cartesian plane in order to draw the tail to head, to draw the right angle triangle using a tail to head method. Okay, this is our Cartesian plane. Okay, I'm going to start it from here. So first of all, we're going to draw the horizontal. Like the Rx is directed to the right, so it means it's going to have tail to head. So this is the Rx with a magnitude of 8.97. Then since we're using tail to head, then we have to construct another one here. Ry, it's directed upwards, 30 points, so it's going to have tail to head upwards. So we'll have tail to head. From here, we put another tail to head. So now we're going to have two components. We have Rx and we have Ry. So this is our Rx. This is our Ry. Then we have to draw a resultant. And to draw a resultant, remember when you're using tail to head, where there is a resultant, you must have two heads and two tails. So to do that, it means you're going to say, here it's our resultant. Tail to head. So we'll have this. This will be the tail to head. So this will be our resultant because we have two heads and two tails. So this is our resultant. And since this is our resultant, we have to construct the, must also have the angle. This angle here from the x-axis. From the x-axis, it's our angle. From the x-axis, it's our angle. And now, to do that, we're going to use theorem of Pythagoras. I apologize. Theorem of Pythagoras states that the r squared is equal to the x squared plus the y squared. What is the r squared? The r squared is the hypotenuse. There is going to be the r, the bigger r. The x is the rx, and the y is the ry. So doing the substitution, the rx will be 8.97 squared, and the ry is 30.21 squared. So we can apply the roots, then that will give us the answer. 8.97 squared plus 30.21 squared. So this one will give us a value of 9993.105. Then we apply the root sign, the root of the answer. That will give us the R of 31.51 Newton. 31.51 Newton. I believe you guys are following. And then now, so we have answered the first question. Then the second question says you need to calculate the direction, but by considering a bearing. I think I explained what do you mean by bearing. A bearing is an angle that is measured from north. So remember this point here, it's our Cartesian plane. So this is our north. An angle that is measured from north, but in the clockwise direction up until to the resultant. So it means this is the bearing. We want this angle here. And since we want this angle, the whole of this angle to the x-axis is 9 degrees. So it means you must first get this theta here. If you get this theta, then from 9 to subtract the theta, then we'll get the bearing there. And how are we going to get the angle? Remember, tan of an angle. Tan theta, it's opposite over adjacent. No, I mean to say to get the theta, not the bearing. So what is the opposite? The opposite is ry of the theta. The adjacent is the rx. So we can get the theta. Ry, what is the ry? 30.21. Rx it's 8.97. So let's make theta, like let's determine the angle here. So the angle will be second function or the arctan of 30.21 divided by 8.97. So we'll get a value of 73. Let's say just say roughly 73 degrees or 73.46 degrees if we were to round to 2 decimal places. So now the 73 points is this angle here. And it's actually, we want the as a bearing. So it means here as a bearing, we'll say 90, because the whole of this angle is 90. 90 minus the theta. The theta is 73.46. So this will give us a value of 90 minus 73.46. This will give us the value of, let's just say 17 degrees. So it's 16.54 degrees, which is roughly 17 degrees. It's roughly 17 degrees. I believe you guys are following. I believe you're following. Okay? I believe you're following. Okay. All right. This is what we're supposed to address in part 1, tail to head method. I don't know if I missed something, but I believe everything it's fine. I believe everything is fine. But if they did not say anything about they just said the direction, we can just consider the theta only. We can consider the theta. I believe you are following. Okay. Right. Let's move on to the next session. Right. Actually, part 2, today actually I want to address the issue of equilibrium system. The issue of calculating resultant forces, we have addressed it in part 1. Today I want to talk about the equilibrium forces, actually. Forces that are equilibrium, or a system that is in equilibrium. And I think I've explained what you mean by an equilibrium system. Okay, without wasting time, let us now go through the questions that are relating to equilibrium. Then, if you do not understand something here, kindly make comments in the video. Then I'll be able to attend to your questions. Okay. Kindly don't forget to subscribe, like, and share. Okay, right. Let's move on to the next one. Question 4, here it's another example of determining the result. You can go through this on your own, resolve forces into components. And it's very important, guys, to know that in most of the cases when a force is acting, or when a vector, not necessarily a force only, but when a vector is acting at an angle, you need to resolve that into components, particularly in grade 12 when you're dealing with Newton's laws. So it's very important to be able to know this. Right. Yeah, let's talk about equilibrium system of forces. What do we mean when we say forces are in equilibrium? Forces that are in equilibrium, it means the net or the resultant force acting on that system is 0. We have a 0 resultant force. So it means the forces are actually balanced. Right, if you look on the question, it says the four core planar forces shown in the figure are in equilibrium. They are in equilibrium. They told us that these are in equilibrium. And you must know that forces that are in equilibrium, if the forces are in equilibrium, it means they are balanced. It means their net force, the net force is 0. Both vertical and both horizontal, it's 0. It's 0. They are balanced. So it's very important to consider this. So according to this question, it says, let's look at the question. It says, determine the value of x and the value of y. We want to know what is the value of x, this x here, and we want to know what is the value of y. The x and y are actually the forces, they're just forces. So what you're going to do, we're going to simplify. Since we are told that the system is in equilibrium, let's give these forces names. I can call them Fy, Fa, Fb, there is no problem with that. Okay, fine. Let me call the 24 Newton as my Fa, the X as my Fb, the Y as my Fc, and the 40 Newton as my Fd. But when you look on this system, force A of magnitude 24, it's acting at an angle of 30 degrees from the horizontal. So it means we need to have components. It must have components. Same applies. The FD is also acting at an angle of 60 degrees. It must also have components. But if you don't want to use the 60 degrees, you can say, if it's 60 here, it means there it's 30 degrees. It can either use the 30 degrees or the 6 degrees, because this must add up to 90. Same applies. If here we have 30, here it's 60. Because 90 plus 90 forms 180. So it's either we use 30 degrees or 6 degrees. But this time around, we can choose to use 30. Even if we use 60, the answer will still be the same. We'll still have the same answer. There's no problem with that. So what are we going to do here? We have to resolve our forces into components, especially for the Fa and the Fb. So we're going to do this. We're going to say, let's resolve Fa into components. Resolving Fa into components, already we have Fb. Fb is already x. And Fb is the horizontal force. So let me just do this. Let's say we want to consider horizontal forces. and also vertical forces. What is our horizontal? Our horizontal, we can say for now we have FB. FB is that X. It is the X. Apology. It is the X. Then now, and what is its direction? To the right. Vertical, FC for now. It is the Y. What is the direction? Downwards. So now we have to resolve FA and FD into components. So we're going to use tail to head. So tail to head method. So we'll have tail to head. And at the same time, we'll have tail to head here with an angle of 90 degrees. So it means this will be the FXA and FXY. Oh, FYA, sorry, I apologize. FYA. FYA is the vertical. And FXA is the horizontal. So I'm going to say FXA is the horizontal. Horizontal is this side. So it's FXA. FYA is the vertical. Remember, both our components need to have FA both sides. One uses sine, one uses cos. Let's look at the angle state here. So this is the opposite. So it means this FYA is the opposite. It's the one that uses sine. So sine 30. And this one uses cos 30. And what is our FA? FA is 24. So we're going to have 24 cos 30. 24 cos 30, 24 cos of 30. This gives us 20.78 Newton. Direction, right. This side, 24 sine 30, sine of 30 is half, so which gives us 12 Newton up. I hope you are following. And same applies, we need to resolve the FD into component. So we're going to have tail to head. So we'll have tail to head. Then tail to head. With two heads and two tails. So this will be the FYD and the FXD. FXD is the horizontal. So I'm going to write it this side on the horizontal. So we'll have FXD and this side will be FYD. Both will have FD. Both will have FD. This uses opposite uses sine. Sine 30. And this one uses cos 30. Remember, you can also use the tail to decide with the angle of 60, still fine. So what is our FD? FD is 40, so it's going to be 40 cos 30, 40 sine 30. Sine 30 is half. This gives us 20 Newton. So FYD is upwards here. Here, it's 40 cos 30. This gives us 34.64 Newton. Direction up, upwards. Then down, up, up. Then now, 40 sine 30, it's 20, okay? Then now we have, let's check. The verticals, it's 1, 2, 3. 2 are directed upwards, 1 is down. Horizontal, we only have the 1, 2, and 3. 2 are right and 1 is down. So, okay, fine. I'm missing left. So we know the net force because the system is in equilibrium. I'm going to say let's start with the horizontal. The sum of the horizontal forces should be 0. When we add our horizontal forces, the sum should be 0. Why? Because the system is in equilibrium. So let's start with the horizontal. Horizontal forces, one is directed to the right. So we're going to have right is plus. We're choosing right as plus. Oh, I mean to say, I apologize. This shouldn't be upwards, guys. It's just, what is the direction for this one? Should be left. Yes, F, it's left. Okay, then now it means here we'll have minus for left. So it means you're gonna say FB FB, it's right, plus XA minus FXD, this must be 0. What is our FB? It's X. FXA is 20.78 minus FXD is 34.64. This must be equals to 0. So this will give us 20.78 minus 34.64. This will give us of negative 13.86 equals to 0. Then we can get the x. The x is 13.86. So we got the value of x is 13.86 Newton. And now we have to also determine the value of y. So to determine the value of y, we'll do the same. Plus, plus, minus, okay? 24 cos 30 minus 40 cos, okay, it's fine. So now the second one would be, we want to determine the y value. The y, it's the vertical force. So since the system is in equilibrium, we're gonna say the sum of the forces that are vertical should be 0 because the system is in equilibrium. So let's check. We have up positive, down negative. So it's going to have FYD, it's up plus FYA minus FC. This should be equals to 0. So what is our FYD? FYD is 20. FYA is 12. And FYC is the y equals to 0. So we can make y the subject of the formula. This will give us 32 equals to y. So then we know that the x is equals to 13.86 Newton, and the y will be 32 Newton. So we'll answer the equation. So we must consider this, that when the system is in equilibrium, the net force that are acting in that system is 0. I believe you are following. I believe you guys are following. Okay? Right, let's move on to the next question. Remember, practice makes perfect. Okay, right. Then in the next question, we are also asked to determine the three coplanar forces shown in the figure below are in equilibrium. Then determine the value of x and y. Still the same as what we're doing, but this time around the x and the y are at angles. They're at an angle. One is at an angle of 30 degrees from the x-axis, and the other one is with an angle of 6 degrees from the x-axis. So you can try that on your own. I apologize. Then, yeah, then remember, practice makes perfect. So we have another one here. There's another one, but this time around we want to determine the angle. Yeah, let's look at this one. It says, okay, determine the value of x and the value of theta. I want to know this value of theta here. But this one is straightforward. It's straightforward, this one. The system is also in equilibrium. The system is also in equilibrium. So first of all, what are you going to do? We can give this name instead. This is our F1, F2, F3. But already we can separate in terms of the vertical and horizontal. Vertically, we have F2 with a value of 20. Remember, vertical we are just meaning upwards or downwards, but downwards here. Then F3, there's a magnitude of X, but left. So it's horizontal. So it means we need to resolve the F1 into components. Resolving F1 into components will have this. We'll have, let's use tail-to-head method and tail-to-head method. So this will be the fx1, or no, I'm going to say fy1 and the fx1. So the fx1 is the horizontal, so we're going to put fx1 this side. Is the horizontal. No, it's the horizontal. So, oh, sorry, I apologize. I said this is horizontal. I said vertical both sides. Okay, this is the horizontal. So it means now we're gonna have so we have horizontal forces. So another one will be fx1, then the vertical here is gonna have fy1. So because both are components of F1 will be part of. One will use sine, one will use cos. So this is our theta. So this will be sine theta, and this will be cos theta. We want to determine the value of x and the value of y. And by the way, what is the direction for F1 sin theta? Up. F1 cos theta, fx1, F1 cos theta, it's right. True, because this is directed to the right. This is up. Okay. So now, to do that, we're going to say we know the system is in equilibrium. First of all, we'll say the sum of forces in the horizontal should be zero because the system is in equilibrium. So let me just write it here because this is where we have the horizontal. Right, by the way, we have two forces. One is right, we can choose right as positive, left as negative. So we're going to add this and we minus this. So we're going to have fx1. But practice makes perfect, guys. Fx1. So we'll have fx1 minus f3 is equals to 0. So what is fx1? fx1 is f1. We don't know f1. Oh, we know f1, by the way. Okay, f1, we do have f1. It's 40. We have f1, it's 40. We have the magnitude of f1, it's 40. So since we know the magnitude of f1 is 40, so we'll have 40 here. We'll have 40 cos theta minus x equals 0. We have two unknowns. Let's make x the subject of the formula. This is equals to x. So we have two unknowns. We're going to make this equation 1. Let's come this side. This side, we're going to say the sum of forces of y is 0. We're going to take up as positive, down as negative. So this will be f1 y minus f2 is 0. So this will give us f1 sine theta equals to, f1 sine theta minus f2. Oh, we already know f2, but it's fine. Let me just write f2. So what is my f1? F1, we know it's 40. So I have 40 sine theta minus, what is our f2? F2, we know is 20 equals to 0. So we'll have 40 sine theta is 20. Then we divide both by 40. So sine theta will be half. And to determine the angles, so we're going to say arc sine or second function sine of half. And this will just give us the degrees. And since the angle, we know the angle, it's 30 degrees, we can now determine the x. And determine the x means we know x equals to 40 cos theta. We know that theta is 30. So it will be 40 cos 30. And the answer becomes 34.64 Newton. 34.6 Newton. I believe, guys, you're following. I believe you guys are following. Okay, let's move on to the next question. Okay. Practice makes perfect. If you practice as many questions as possible, then you will enjoy. Okay, all right, let's move on. It's the next one. Question 8, let's check question 8. Question 9, it's roughly the same as question 8. Then question 2, and the inclined plane, question 3. Okay. Okay, about this one. Okay, let's look on question. 8 and 9 are roughly the same. Okay, let's look at question 9. Sorry. In question 9, it says the figure above shows a particle that has a mass of 10 kg, a mass of 10 kg. So this particle has a mass of 10 kg. We're given a particle that has a mass of 10 kg. It's suspended by two strings or two strings. We know the force on a string is called a tension. It means there's a tension here and there's a tension, but these tensions are not the same. Okay, from a fixed horizontal ceiling. Okay, from the fixed horizontal ceiling, the particles hangs in equilibrium, which means the net forces here, the forces here are balanced. The strings are light inextensible and are inclined at 30 and 60 to the ceiling. Find the tension in each string. Okay, sorry guys. We want to calculate the tension in each string. Okay, to do that, we can give them names. We can say either we say tension 1 or tension 2. There's no problem with that. Please, guys. Okay. Then we can say the first one, let's just give it a name. Let's call this the first one tension A, and this let's call it tension B. It's my choice. First of all, we need to identify angles that are actually acting here. Since this object, this has a mass of 10 kg and it's actually hanging, it means there is a force of gravity. There is a force of gravity that is actually acting here. You can call it weight or W. So you can call it Fg or W. And how do you calculate force of gravity, guys? To calculate force of gravity, we use mg. And what is the mass? The mass is given as 10. Acceleration, gravitational acceleration 9.8. So that will give us 98 Newton. But where? Downwards. I believe you're following. But now, look, these forces, the TA and the TB, they're actually acting at an angle. So what we can do is it's either we use this angle of 6 degrees or we can change them like this. Let me show you. Look here. If this force is acting at an angle, and I don't want to use this, I want to use the other angle here, I will do this. It's either from each force I can make components in this manner. I can say from, this is the result, I can say we have tail to head. And also have tail to head here. Okay. So we have tail to head, so we're gonna have something like this. So it means now we're gonna do this, we're gonna say, okay, fine. Within this, but we can also use that angle of 6, there's no problem. 6 and 30. Now, look here. This will be my T YA, and this is my T XA, not F, but T. So it will be the T, let me use, so it will be the T YA, and it will be the T XA. Then now look, here, this angle here it's 30, which means this angle should be 60 because it must add up to 90. And if it's 60, there is 90, you can say this also is 30. So it's like having alternate angle. When we know this angle here is the same as this, we can put it there or there. There's no problem. So it's either we use 30 or we use 60. The answer has to be the same. I believe you are following. So it's either we say, okay, fine. So we have this angle. Here it's 30. So this will be 60 because this add up to 90. If it's 60, there it will be, we'll have 30 again. So it's either we use 10 degrees or 60 degrees, the answer will be the same. I believe you're following. Same applies with this one, this side. Okay, let me just use a different color. If we say this is tail to head, so we'll have another tail to head here. So there's 90. So you see, if it's 60 here, there will be 30. We'll have 30 degrees. And if it's 30, this will be 60. Because this is like alternate angles. This angle and that angle are equal. So we can either use 60 or we can use 30. There's no problem. There's no problem. So it means for now on my side, I'll use the 60 and the 30. But even if any, there's no problem. Then now it means this will be TXB and TYB. So now let's resolve this into components. I believe you guys are following. Remember, someone might do tail to head with an angle of 6. There's no problem. There's no problem. Still the same parallelogram. I believe you're following. So now we're gonna say, okay, fine. Now we have the let's separate this. I want us to have vertical forces only, and I also want us to have horizontal forces. Remember, the tensions are acting at an angle, so they must have component. So it means, let's start with the horizontal. The horizontal for the TA, it will be TXA. And the vertical for TA, it will be TYA, which will just be TA. And since I want to use this angle, I can either use 30 or 6, there's no problem. But for now, I want to use 30, it means that this will be the opposite side. Use sine 30. And this one will be this will use TA cos 30. I hope you are following. I want to use this one. Right, how about the vertical? Oh, the horizontal for TB. TB horizontal will be TXB. Vertical will be TYB. Oh, what is the direction of TYA? TYA, it is up. TX, it is right. Okay, then TYB is this one. This is, since I want to use 6 degrees, this will be the opposite. So it will be TB, opposite uses sine, so sine 60. And what is the direction for that? Up. So this side, TB for X, direction is left. So TB uses cos 60 if I want to use 60. But if I want to use 30, it will be sine 30. And what is the direction? Left. And we are left with, on vertical, we are left with force of gravity. It's 98 Newton, direction down. I believe you are following. So we have almost, in terms of components, we have 1, 2, 3 forces that are vertical. Horizontal, we only have one, this one, and this, which are horizontal. One is to the right, and one is to the left. So in terms of our choice, let's choose right as positive, left as negative, up as positive, positive, negative as down. So because we are told that the system is in equilibrium, so we're going to say the sum of the horizontal force is 0. Sum of the horizontal forces is 0. Horizontal is these two. So we're going to take TXA and minus TXB equals to 0. So what does it mean? It means TXA is the same as TXB. They're equal. So what is TXA? TXA is TA cos 30. TB is TB cos 60. So this is what we have. And what is cos 30? Cos 30, it's actually root 3 over 2. So it's going to have root 3 over 2 TA. And what is cos 60? Cos 60 is half. So this will be half TB. So you see that we have two unknowns, TA and TB. So which means for now, what you're going to do, you can just leave that for now. We have this. So now we move on to the next one. For the horizontal, we are sorted. Now let's move on to the next part. Now we're going to work out that one for the vertical. So we're going to say the sum of the force for vertical is also 0. Vertical we add with the up one, so it's going to be 2YA plus TYB minus FG equals to 0. Because 2 are up, 1 is down. So what is TYA? TYA is TA sine 30. And what is sine 30 is half. So we're going to have half TA. I hope you are following. Sine 30 is half. So plus, what is TB? TB it's TB sine 60. What is sine 60? Sine 60 it's root 3 over 2. So we're going to have root 3 over 2 TB. Okay? Then minus FG, which is 98, equals to 0. Let's do this. Half TA plus root 3 over 2 TB equals to 98. This is equation number 2. Number 1, to know the tension. Then we're going to do this simultaneously. So we're going to say from the equation here, the main ways to skin a cat, let's make either TA or TB the subject of the formula here. So it means in this expression here, we know that root 3 over 2 TA is equals to half TB. So let's divide everything. Let's divide both by half, or we multiply by 2. There's no problem. We multiply the whole equation by 2, or we divide by half. It means this will be root 3 TA equals to TB. I hope you understand what I've done there. It's either we divide both by half or we multiply. So you see that we made TB the subject of the formula. So it means in this equation, where there is TB, we can put root 3 TA. So it's gonna be half TA plus root 3 over 2. Algebra, guys, algebra. So where there is TB, you can put root 3 TA equals to 98. Because TB equals to this. I believe you are following. So you're gonna have half TA plus, let's multiply this. This will give us 3 over 2 TA equals to 98. So when you add 3 over 2 and 0 0.5, half plus 3 over 2, this will give us 2A. 2 equals to 98. So we divide here by 2. 98 divided by 2, then this will give us a force of 49 Newton. And since we know a force of the TA 49, then we can come and calculate TB, because TB is the root of 3 TA. So we're going to say root 3 TA. What is TA? 49. So multiplied by root 3, this will give us 84.87 Newton. So if we are rounding this to the nearest, that will be roughly 85 Newton. If we are rounding to the nearest. I believe you are following. I believe you are following, guys. Remember, practice makes perfect. Okay. So you can try the question 9 on your own. Okay. So those are the answers. Practice makes perfect. Remember, this is for both grade 11 and 12, but usually it is examinable in the grade 11 paper. So make sure that you understand systems that are in equilibrium. If you read the question, then they're telling you that the object it is in equilibrium, then you know it means the net force is equal to 0. And this also applies in terms of in Newton's law, especially also in grade 12, because, for example, if an object is moving horizontally, obvious, the object that is moving horizontally, it means the vertical force on that object are in equilibrium, are balanced. Because the object cannot move upwards and horizontal at the same, vertical at the same time. So if you have an object, let's say you have an object. Let's say you have an object, like the object is moving horizontally. And maybe there is a normal force, there is force of gravity. Let's say there is force applied, there's just an example. And there's also frictional force. Oh, I apologize. It should be small. So in that case, it means that if the object is accelerating horizontally, it means the vertical forces are actually in equilibrium. So you're going to say sum of the vertical should be 0 because they're balanced. So it's normal minus Fg is equals to 0. So normal equals to Fg. Then you calculate the using mg, then you calculate, maybe you want to calculate the frictional force using the formula, the mu k multiplied by normal. So you see vertical force are in equilibrium, or are in equilibrium because the system is moving horizontally. So it's very important to know that. So it's also applicable in grade 12. Is that in some instances they're not telling you that the system is in equilibrium. So it's you who should think. Okay. Okay. So question 9, it's related to question the one, even this one, you can also try to solve it on your own. Then the other one, it is Apologize, guys, apologize. So this is an inclined plane. So you can go through this on your own, wherever you are facing some challenges. Kindly get back to me. And this also is important for both grade 11 and 12, for the inclined planes. So there's another one, which says that the figure above shows a box of weight W Newton. So it means this object has a force of gravity of W. We know in terms of the slope, the force of gravity will be in that direction. So this is our weight. And since this is the weight, then the angle here, if it's 20, then it will act at an angle of 20 there also. So we know any force that acts at an angle must have components. So it means we need to resolve that weight into components. So you're going to have tail to head and also tail to head. So since there's an angle of 90 degrees, we're going to call this W perpendicular, and this one is called W parallel. So these are the components of W. So we have W perpendicular and W parallel. Both will have W. One must use sine one. So this is the opposite, or this is the opposite, means this is the one that if you use sine 20, this must use cos 20. And you see also this force, I think it's the force applied. It's also acting at an angle of 40 degrees. So it means you must have tail to head, sorry, and also tail to head. So we're going to call this, let's call this Fx and Fy. So we have the components of F. So this will be the Fya and Fxa. So both will have Fa. One uses sine. Okay, we're going to have sine 40 and cos 40. So we have the Fa is 200, so it's going to be 200 sine of 40 and 200 cos of 40. That will give us the value. And they're saying again, the above shows a box of weight W, okay, resting on a plane inclined at an angle of 20 degrees. It is kept in equilibrium, so it means the net force here is zero by a force of, okay, acting up at an angle of 10 degrees to the direction of the greatest slope. Okay, then now the box is experiencing a frictional force of F Newton. So we're given a frictional force of F Newton down. So down means it's this side. So there is a frictional force here of F Newton. Then, and the normal reaction between the box and the plane has magnitude. So we're given a normal force. We are given a normal force. So there's a normal force of 180 Newton. So now, what is the question? By modeling the box as a particle, find the weight and the force F. So you want to know the weight and the frictional force. And remember, you have to also do what I've said, like in terms of components, you look at the vertical and horizontal. Okay, how many vertical are here? The vertical is the normal. The vertical is the normal force of 180 Newton, which is up. W perpendicular, it's also vertical, which is just W cos 20, which is down. And also we have this Fya. It's also a vertical. Fya, we have it is there. It's 200 sine 40. So it's up. So we have up, down. So horizontal is the Fx, Wx, and the frictional force. So these are the horizontal forces. The first one is the Fxa. Fxa, we can calculate it as 200 cos 40. We can get the answer. Frictional force is the F, which is, we can just say left this side, and the weight parallel is W sine 20. Can also say left because it's moving left that side. So this is right. So you see we have plus, we have minus, and we have minus. So we can say the sum of the vertical force is 0, and the sum of the horizontal force is also 0. So you can add this and calculate W, because we have this already. We have this, we can get the W. And here we'll have to ask to get the F. So you can do this. So let's check 200 sine 40. 200 sine 40 to give us 128.56 Newton. Then same applies 200 cos 40. This will give us 153.21 Newton. And FYA is up, this is down. So we can do that. So here we can say the sum of the force X is 0. X is this one, right? So we're gonna have FXA. FXA, we got it's 153.21. Is down, okay, right? Then minus the F minus W sine 20, 0. Here we have two unknown. We don't know the F, we don't know the W. So it means you must go to the one for the vertical. Vertical, we have normal, it's up, so it's normal plus FYA minus W perpendicular equals 0. So we have the normal, it's 180. We have the FYA, we have it's 200 sine 40, which is 128.56. So we can transpose this one perpendicular to the right. So which means that W perpendicular would be 180 plus 128.56. So this will give us 308.56. So W weight W, we know it's W. I'm saying the weight perpendicular is W cos 20, which is 308.56. So we can divide there by cos 20, and we divide there by cos 20. So it will be 300 divided by cos of 20. So it will have, we'll get a weight of 328.36 Newton. So since we know this, we can now revert to where I said we have two unknown to get the F. So to get the F, we're going to say 153.21, don't know the F, minus, we know the W is 328.36, so sine of 20, this should be 0. So we're going to say 153.21 minus 328.36 sine of 20, if I'm not mistaken. So this will give us a value of, the F will be 40. Newton, which is just roughly 41. If we were to round this, friction will be roughly 41 Newton, then the weight will be roughly 328 Newton, if I'm not mistaken. Okay. So I think I will stop here, guys. Thanks for listening. Hope you enjoyed this video. Bye-bye.